So let's see. Okay, it's being recorded. Let me start sharing my screen. I hope you can hear me well.
Yes.
Now you can see the slides and a pointer.
Yep.
Perfect. So this first talk is kind of not about code, but more about keeping your code alive. So I give another set of talks, which is called Made Your Code Count, which is more about how do you develop your own open source code and kind of adhere to the standards that any open source project should have. But this is more like, yes, you know how to make code, you have open source your code, you have nice documentation, now what? How do you kind of continue developing this code and keep it alive for years for others to come? And I will take a mix of example, one from QuTiP, because I'm involved with this project. It's almost a 10-year-old project now, and Numpy, which is numerical linear algebra module in Python, and kind of trace a little bit their history and try to draw some inspiration from how these two projects survived so long. Yes, so this is the Hack MD. I guess we already talked about it. You should kind of check it out and add questions, discussions already at the bottom of this link. So a question that came to my mind is, I've been using Numpy since my undergraduate time, but I never thought about who developed it, how does it get funding, who put the time in, and what's the history. So for this presentation, I sort of traced back the origins of Numpy. And it turns out that already in 1995 to 2000, there were two libraries, one developed in Lawrence Livermore National Lab and one in STSI, which is operated by NASA. And these two libraries, numeric and num-array, were sort of the precursors to linear algebra routines in Python. So they were supported by people who were working there, the salaried professional researchers, and they kind of made these two toolboxes for internal use. And then it proliferated and other people started using it and found it useful. And then it split because this numeric was not so good for large matrices. And the other one, num-array, which was good for large matrices in astronomical data, was not so fast. So they had problems and they split. Then in 2005, Travis Oliphant at Birmingham Young University, and he was already, he had, I think, a tenured position. He was a professor there. He started kind of compiling these two versions, numeric and num-array, into Numpy. So this was kind of the birth of Numpy. So he was still paid at the university, but then later he moved into industry, this company called Nthought Software, and later co-founded Continuum Analytics, which is the company that made Anaconda. If you use Python, it's a package manager. So I found like a nice tweet by Wes McKinney. I think he created Pandas about Travis. So the ecosystem probably would have never got started without academics spending time writing software instead of paper. So they were kind of doing it before it was even rewarding to do so. And that led to the birth of Numpy. So this was still many years back, 15 years back. What is the situation now? Only in 2017 did Numpy get some funding. So 640,000 from the Moore Foundation. And when this came up, this small little blog post, the NumFocus organization where this blog post came about crashed because people were so shocked that something like Numpy had got funding just in 2017. So then they had like a steady funding, I guess, to hire developers, which was used in a lot of things like rewriting the documentation and making the project much better. So what's kind of the message that we can see from here? That it started off as an academic project with professionals whose main job was to do research, but they spent extra time developing this. And then it took almost 15, 20 years for it to get funding. And currently it's still getting funded by these initiatives, not directly by academia, but these initiatives and some institutional partners. And what is the key here for at least me and this maybe RSE is Institutional partners are the organizations that I think can do the maximum to help develop open source scientific software. So now they have Berkeley, who's an institutional partner supporting Numpy, and this company called QuanTiP. And I think in 2020, end of 2020, they also got another round of funding from the Zuckerberg initiative. Okay, so that's the story of one organization, Numpy. In the HackMD, maybe you could write your favorite open source tool, and later on we could try to figure out how did they manage to survive, who is funding them, and so on. But let's look at some other more successful toolboxes. So one is TensorFlow, which is a toolbox that is used to develop neural networks. So the precursor to TensorFlow was something called Theano. And this was kind of developed by maintained by one person, Yoshua Bengio at Montreal Institute for Learning Algorithms. Then a bunch of people kind of took over, developed it, and then Google took over and made something called TensorFlow, which is modeled on this Theano. There was another person who developed a kind of abstract API on top of whatever low-level functionalities Google developed to make it easy for users to use TensorFlow, called Keras. And then Google, of course, hired that person, and he works there now as head of development. Similar story for this tool called Torch, PyTorch, which is now developed by Facebook. So the precursor was something called Torch, which is not in active development anymore, but the maintainers kind of got absorbed by Facebook, DeepMind, and Twitter. So here is a very different thing that got funded really fast, a huge amount of funding, big team, and these are very big successful projects now. But they worked because industry got interested in them, and it's something that the industry used, so they found value. Can academics always do something like that? So for example, there are some projects, AstroPy, NiLearn, DiPy, which is diffusion imaging in Python. They're not necessarily as attractive to the industry as TensorFlow and PyTorch. So how should something like that get funding? So the answer, at least that's what I want to discuss, is institutional funding or support from academia. And one of the examples that I know personally is of quantum software. So in 2002, already there was something in MATLAB that was developed by a university. In 2012, Paul Nation and Robert Johansson, who were researchers in the group of Franco Nori, it's kind of a happy coincidence that they were together at the same time, and Professor Nori encouraged developing software. So they had separately developed something. So Robert had developed C++ routines for fast simulations, and Paul had some Python code, and they merged and started developing this software called QuTiP. And you can see that after that, there has been a lot of institutes as well as companies like IBM, Rigetti, Google, Microsoft, who have been trying to develop similar software, quantum software. But the interesting thing is none of these later softwares have come close to the impact that QuTiP has produced. So you can see why it is so popular and successful is because it is allowing researchers to simulate all kinds of quantum physics. And the story of QuTiP is basically two researchers who tried to develop their code and the supervisor who said, yeah, it's okay. You don't have to maybe 100% focus on just producing papers. You can produce a scientific code. And then they wrote a paper. The first papers were very short, a couple of pages. But the main thing that they gave was the toolbox. And then you can see that if you look at the acknowledgements page of the papers, there's a lot of different organizations where the funding was kind of siphoned into supporting these two developers initially. And now, of course, we have got affiliations with NumFocus, and there's something called Unitary Fund. I study at Chalmers, and kind of Chalmers is also paying for it. So you see most of it is coming from institutional funding. And it has led to a lot of impact in the quantum simulations community. So already QuTiP has 1,500 citations. is used in papers that are getting published from different areas. It's used in companies, even got a mention in The Economist or the Numpy paper. And here are like some of the very recent examples I just picked up, which cite the paper QuTiP. So one of the good things that happened was the code was there, but now to get real metrics, there was the paper also. So you could really see how the code was being used because everyone was citing the paper. And personally, I think one of the biggest reasons for its success is the large amount of tutorials, documentation, and code snippets that QuTiP gives. Like you could go to this website and find basically all kinds of things in quantum simulations that you can do with QuTiP. And this led to this culture that, okay, if you did something cool with QuTiP, people were coming up and publishing their own work as notebooks on the website, and we are kind of encouraging them. So it's growing in itself. So like this slide is basically what is the key point that I think that makes a project like QuTiP continue. It's institutional funding and support from someone who recognizes that code is a really, really important part of scientific research and encourages it. So every time the new developers of QuTiP were from this group of Professor Franco Nori. So I was there at one time during my master's thesis. Nathan was there as a postdoc. Neil is still there and he is working actively on his own research, but also supporting QuTiP. So there is an environment created here because the PI realized that, okay, this software needs to be promoted and allowed the opportunity for people to work on it. And we have benefited greatly from it. I got my first scientific research because of a project that I did with QuTiP. And then there are specific job opportunities that has been created for maintaining QuTiP. So we have a new hire who's a a research engineer in the group, not a postdoc or anything. And like because of this success, we've been able to get more funding and grants specifically just for QuTiP. And then what happened was other institutes took note and they started assigning specific people like Eric from Alexandra Bly group in Sherbrooke, who has dedicated time every week to work on QuTiP. Similarly, Nathan, who is working on a nonprofit organization called Unitary Fund, contributes time, and they're getting paid from these institutions directly. And then another channel for keeping QuTiP alive has been Google Summer of Code. So this is a program by Google where students and mentors are connected and Google pays the students to work on a project in the summer. And we got 2 people from the previous GSOC programs that became full-time contributors and maintainers at QuTiP. And this year also, we got 3 new very interesting projects and students. So we wanted to do something with GPUs and there were no developers who could work full-time on it. So what we did was we made projects where students can start this and then we present this to the community and hopefully the community picks it up and it continues. So these kind of efforts also led to development of an entire ecosystem around QuTiP. So other people who found it useful forked it and used it in different ways. And then we are kind of saying that, okay, we provide the main core functionalities and you can take and reprogram it to do other things. And that has also been very phenomenal success for our QuTiP. And we can see the similar idea in Numpy. So people started using Numpy, QuTiP uses Numpy and many other organizations. So if you're solving a basic problem and creating an ecosystem, you can see that your tool becomes more and more useful and survives. So we have like a governance model at QuTiP that is helping us maintain things. So we have an admin team, a dev team that has different level accesses, a board which consists of PIs and big people, probably who have big groups who can get funding and who recognize that a project like QuTiP should continue getting support. And then we have fixed that every month, the core team is going to meet regularly and discuss new ideas, Google Summer of Code, and so on. This brings me to kind of the conclusion of this small discussion presentation is usually projects are started in academia by students, postdocs, researchers, and they become valuable to industry and they get picked up. But maybe for scientific projects, this is not so straightforward. So even though the initial funding comes from academia, something institutional is required to keep it running. We could also look at other models, for example, the Apache Foundation, Python Software Foundation, or NumFocus, which is not getting funding from academia, but from companies. So they have a model where they ask companies to pledge money, but maybe something like that is not necessarily working for scientific software. And what we need is institutional funding and people that will be supported at universities, research groups, and paid from the funding from grants. So this brings me to the end of this discussion. I hope I'm on time. Yeah.
Yes, you would still have 4 minutes if you want to.
No, okay, we can take questions and discussion maybe in 4 minutes. So I can say I'm done. Yeah.
Okay, thank you for the very interesting talk. I believe this topic is of interest to many people visiting here today. And I see that there's already some stuff going on in the HackMD. There are a few shorter questions. Someone is asking, what is your personal background? Are you doing a PhD or hired to do code development?
So my personal background is I'm doing a PhD. But I have to say that I got this PhD because of code development. So it's an interesting story. I was doing an internship during my undergraduate, and I came across a post on QuTiP's website that they're looking for someone who has some experience with coding and physics knowledge, and they wanted to hire a research software developer. So I applied, and then at that time, since I was still not done with my master's, they said, okay, you can be a master's level intern here, and you could simultaneously work on science and help develop this code. And that was kind of my entry into the whole field. And it worked out really well because I was developing the code and simulations, but at the same time, also working on the science, the physics of it. So yeah, it's a mixed situation.
Sounds like a great start. Let's see. Yeah, we still have a few minutes, so we can take either of those questions. So there's some comments that we can go back to maybe in the Q&A session. And there's one question, can the choice of software license make this so whether a project survives easier or more difficult?
I mean, if you pick any open source license nowadays, I feel like it should work, like the BSD3 MIT license, it works. If you want to be more restrictive, I would say that it shouldn't affect so much because, you know, if the code stays in academia, people will cite it properly if they use it, and people will hopefully carry over the licenses. But I don't know, if you're developing something that is starting to get used by the industry, well, it's open source, right? The industry can take it and do whatever it wants with it. The benefit they would have to see is that the community that gets developed using the software is beneficial to them. So they would, instead of taking it and developing it secretly or kind of, you know, doing it internally, they would also want to work with the community. So I think as long as you make a nice community out of your code, the license shouldn't matter so much.
Okay, and then we can take maybe one more now, and the rest we'll leave for the Q&A session. So please, everyone, keep adding questions if you have them. Happy to see so many. How do you get the visibility for code or tools so that it is used by industry, or will this only ever happen in the long run?
Yeah, this is kind of tricky because, you know, if you are like the reason why I know QuTiP is being used by these places at these places is whenever sometimes I talk to people at conferences or something, they're like, oh yeah, you're the QuTiP people. Yeah, we love this. We use this a lot for this simulation, these things. But I don't think it's very straightforward to understand the exposure unless companies, you start identifying it and saying, okay, we have talked to people in this company and we know it's being used there, so we put it on our website. So that could be one option. That's what we do kind of. We know people at these different companies and research groups, and we just say, okay, QuTiP is being used by people here, and there. I could take one more question actually. How many people
Okay.
are working full-time on QuTiP development? So right now we are 6 6 people who are working full-time, well, not full-time. Nobody is working full-time except maybe the Google Summer of Code students for just the summer, but everyone has like some part-time dedicated to QuTiP. Nobody is hired for QuTiP until recently. So we have one person, Simon Cross, who was hired full-time to work on QuTiP by Franco's group. So we just have one person, but everyone else is part-time.
Okay, thank you, Shahnawaz. We'll get back to the Q&A session at 14:05 and continue now with the second invited talk. Thank you so much.